Welcome to the Explainer. So, if you're in the machine learning trenches, you already know the daily grind, right? You're spending countless hours digging through dense research papers, writing that same boilerplate training code over and over, fighting software dependencies, and wrestling with massive data sets and complex GPU setups. It's a highly manual, tedious process. And let's be real, it totally pulls you away from the actual creative side of building AI. But what if we could just automate that entire life cycle?
Okay, let's dive into this. Imagine if an AI engineer actually lived right inside your terminal. And to be clear, I am not talking about a glorified autocomplete that just guesses the next line of code in your editor. No, I mean a fully autonomous agentic system, something that can take a high-level plain English instruction from you and then just automatically execute hours of complex, multi-step workflows, navigating all the hurdles exactly like a human engineer would.
Well, that exact capability is exactly what we're looking at in today's explainer, ml-intern. This is a fully open-source command-line AI agent built by the amazing team over at Hugging Face. And open source is the absolutely crucial phrase here. This isn't some lockdown, super expensive SaaS product with hidden fees and annoying usage limits. Nope, it's a completely free tool, built specifically to automate the machine learning lifecycle right from your own machine. To really grasp how powerful this thing is, we need to take a quick peek under the hood. The core architecture is heavily Python-based, making up about 82% of the codebase, actually. That robust Python core is what's driving the agentic loop and the backend tool routing. The other 18%? That's TypeScript, which powers a really sleek optional web front end, just in case you prefer browsing your sessions visually rather than staring at the raw terminal. It's a beautifully balanced modern setup.
But I think the real magic here lies in its model layer. It uses Light LLM to standardize all its API calls, which gives ml-intern a completely model-agnostic design, meaning you are not locked into OpenAI or Anthropic. Because the agent communicates via the standard OpenAI-compatible API format, you can easily plug in Claude, GPT-4, or even spin up your own local LLMs. You have total control over the brain that's actually driving the agent.
So, how does this agent actually think and operate with that brain? Well, it runs on a continuous tool-using LLM loop, and this brilliantly illustrates how it behaves like an autonomous junior engineer. First off, it receives your instruction. Second, it plans out the exact steps needed to pull it off. Third, it routes those steps to the specific tools it has access to. And finally, it executes the code and evaluates the output. It's constantly checking its own work and iterating, just like we do.
It pulls all this off using a massive suite of built-in tools. And I really want to emphasize this point. It doesn't just spit out text. It actively reaches out into the digital world. We're talking searching Hugging Face documentation, browsing and cloning repos, running remote training jobs, digging through GitHub for code examples. It can even pull down and read archive research papers. It literally reads the science, writes the bash scripts, and routes the execution exactly where it needs to go. Crazy, right? Now, getting started with all this power is surprisingly painless. Let's quickly demystify the setup. You just clone the GitHub repository, install the dependencies using UV, which, by the way, if you aren't using it yet, is Hugging Face's blazingly fast Python package manager, and then you just set your Hugging Face token in a .envio file. That's the whole shebang. 3 simple steps, and suddenly you've got an ml-intern command globally available and ready to work. Once it's installed, you basically have 2 primary ways to interact with it. On one hand, you've got interactive chat mode. This is a conversational REPL-style interface that's absolutely perfect for open-ended exploration, like, say, asking it to read a paper and puzzle out a script with you back and forth. On the other hand, there's Headless mode. This is your rigid, single-prompt automation. You give it a task, it runs it, it exits. It is exactly what you want when you're building automated CI/CD pipelines. If you're hanging out in that interactive chat mode, you get access to some incredibly useful slash commands. The real standout here is the /model command. Picture this. You start a session using a super fast, cheap local model just to do some quick dataset exploration. But then the task gets complicated. Instead of losing all your context or restarting the whole thing, you just type /model, swap over to a heavier reasoning model like Claude to write the complex script, and seamlessly keep going. It's a huge time saver. Conversely, when you're using Headless mode, you control the automation using specific command line flags. You can use the model flag to dictate the brain, sure, but the really important one is the max iterations flag. This acts as your safety net. It caps how many steps the agent can take, which is absolutely crucial for keeping API costs from blowing up if a task goes off the rails.
Combine that with a no-stream flag, and you can literally drop ml-intern right into your makefiles or scheduled GitHub actions. Now, what's really interesting here is how incredibly accessible ml-intern makes local execution. Because it's just talking to standard HTTP servers, you can run the entire agent on your own free local hardware. Whether you're a fan of a Llama, VLLM, LM Studio, or Llama CPP, it doesn't matter. You just start up your local server, slap on the specific provider's prefix, and boom, the agent is using your machine's brain. Honestly, the advantage of this local execution feature just cannot be overstated. By running these models locally, you are looking at absolute zero API costs, complete data privacy for your proprietary data sets, and zero rate limits to worry about. For rapid prototyping, an 8 or 14 billion parameter model running through a Llama right on your laptop is completely sufficient. It's a total game changer that lets you experiment freely without accidentally racking up a massive API bill. But of course, here's where we always hit that classic roadblock. What happens when your script is finally ready, but your laptop doesn't have the heavy GPU horsepower required to actually train the model? Well, enter the GPU sandbox. By throwing in the sandbox tools flag, you can bypass your local hardware limits entirely. Instead of trying to run heavy bash commands locally, ml-intern routes the execution directly to private Hugging Face spaces, tapping into cloud GPUs. You can even set this up as the default behavior in your config file. Let's move to a real-world scenario and see how this builds into a complete workflow. Say you ask the agent to fine-tune the Phi-3 model. Here's what happens. First, the agent reads the Phi-3 and dataset cards. Second, it searches the PFT and LoRa docs for efficient fine-tuning techniques. You know, the tricks that let you train massive models without needing a supercomputer. Third, it writes out the actual training script. Fourth, it automatically provisions a Hugging Face space to train it on a cloud GPU. And fifth, it pushes that finished adapter right back to your hub account, all from one single instruction. And I have to say, here is probably the most astonishing part of that entire process. As the source material points out, if the code happens to crash during execution, the agentic loop actually reads its own error messages and retries. If your training job fails because of an out-of-memory error, or maybe a broken Python import, the agent doesn't just throw its hands up and wait for you to fix it. It reads the logs, modifies the script to fix the bug, and autonomously reruns the job. It literally debugs its own work. So the crucial point is that ml-intern fundamentally changes how we approach building machine learning systems. It truly functions as a full ML engineer, planning and executing tasks in a continuous loop. It's completely model agnostic, giving you total freedom. It supports dual runtimes, meaning you can use your local bash environment or cloud GPUs, and the whole thing is entirely open source and extensible. It drastically shrinks that massive timeline from having a concept in your head to actually deploying a model. The gap between having a great idea and having a trained model is shrinking way faster than anyone predicted. Tools like ml-intern are essentially handing you the capabilities of an entire engineering team accessible directly from your terminal. The friction of the machine learning lifecycle, it's been massively reduced. So I'll leave you with this final thought. With an autonomous AI engineer waiting for your instructions right now, what will you build first? Thanks for hanging out with me on this explainer, and I'll catch you next time.